In this video, we're going to be finding the equation of a straight line, and we're going to look at some problems where we know about our line being parallel to something else. So in this case, we are looking for a line that passes through 1, 7. So if you imagine that that's our line, we're looking for the equation of that line. Now, just having one point on a line isn't enough information to find the equation of it, because I could draw that line like this, I could draw that line like that, so we don't actually know what way the line's going just now. I've just drawn that picture just to kind of prove that point. However, we have been given information about a line that's parallel to it. So that means that if I were to draw a line parallel to it, we know what the equation of this is. And when you have a line that's parallel, they have the same steepness, they have the same gradient. So effectively, we can just say, well, we know that the gradient is 2 of the pink line, so that means the gradient's 2 also of the blue line. So our y equals mx plus c, which is what we're looking for, we now know, just from comparing with the pink line, or comparing with this other equation that's parallel, that we know that m is 2. So y equals 2x plus c. Once we find the gradient then, we use the one point that we were given, 1, 7, and sub it in to find c. So 7 will equal 2 times 1 plus c. 7 then will be 5 plus c, and then c is 2. From that, we can then write our final answer for this equation. Y equals 2x for the gradient, and then c is also 2, so we have plus 2 in the end. Another example of this. Write down the equation of the straight line that passes through 3 minus 1. So I'm just going to make a doodle. Here's a line with a 3 minus 1, and is parallel to a different line that passes through minus 1, 4 and 3, 6. So this one, there's a little bit more work to do. There's another line that exists that's parallel, okay, where we have 2 points on that line, minus 1 and 4, and 3 and 6. So similar to the last one, our blue line, the one that we cared about for finding the equation of, we don't have enough information yet because we've only been given 1 point. Finding the gradient's always going to be the trickiest part of these straight line questions. So we've got a bit of work to do over here in order to find the gradient of that line. But luckily we've been given 2 points, so we can do exactly the same as we've done previously for finding the gradient with 2 points, and that is the rise over run, the difference in the y coordinates over the difference in the x coordinates. I suppose what I should really do is just clarify what's x1, y1, and x2, y2. It wouldn't matter if we did these other way around, as long as the x's and the y's are the proper values. So y2 is 6, take away 4 is y1, and then x2 is 3, take away a negative 1 for x1, so being careful there with negatives. That's going to give us a 2 in the top, 4 in the bottom, so that gives us our gradient as a half, or 0.5. So, coming back to our blue line, we know that y is going to equal half x plus c, or 0.5 x plus c. Now we can use the coordinates of the point that we know are on the line. So x is 3 when y is minus 1. So we sub that in. So we end up with half times 3 plus c. If we do half times 3, we end up with 3 halves, or 1.5 plus c. And then when we take away 3 over 2, or take away 1.5 from both sides, we're going to be ending up with negative 5 over 2 is c, or negative 2.5 is c, whichever way you prefer. Then that's it of everything we need. We've got our gradient now, so I always like writing things in fractions, so that's what I'm going to do here. Half x, take away 5 over 2, but you could also write it as 0.5x minus 2.5 if you so wish. Done.